Today, December 20, 2025, something extraordinary is happening, an event that comes once in a lifetime. A visitor from another star system has just made its closest pass by Earth at a distance of 168 million miles, or 270 million kilometers. It's completely safe, but it won't stay long. In just hours, it will begin heading toward the outer solar system and then leave us forever. This is Comet 3I/ATLS, the third confirmed interstellar object ever detected. And right now, we're saying goodbye to the oldest cometary body humanity has ever studied. What it has revealed to scientists over these past months is forcing us to rewrite astronomy textbooks, because this isn't just a chunk of ice and dust, it's a true messenger from an era when our galaxy looked completely different. It all started on July 1, 2025. The telescopes of NASA's ATLAS system, the same network that constantly scans the sky for Earth-threatening asteroids, picked up a faint, moving object. At first, everyone assumed it was a regular comet from the distant Oort cloud, the reservoir of icy bodies on the fringes of our system. But when astronomers calculated the orbit, jaws dropped. The trajectory was hyperbolic. Its speed relative to the Sun exceeded 30 kilometers per second. That could mean only one thing. The object isn't gravitationally bound to our star. It isn't orbiting the Sun like all local comets and asteroids. It's simply passing through like a random traveler. 3I-Atlas became just the third confirmed interstellar body in observational history. For comparison, the first was the mysterious 1I-Oumuamua in 2017, a strange cigar-shaped rock with no coma or tail, displaying puzzling non-gravitational acceleration that even sparked speculation about artificial origins. The second was 2I-Borisov in 1919, a more classic comet with a huge tail but unusually high levels of carbon monoxide. And the third, our guest today, turned out to be a water-rich comet with a bright coma and a long tail. But the truly mind-blowing part lies not in its appearance, but in its origin. The orbit of 3I/Atlas points not just from outside the solar system, but to a specific region of the Milky Way known as the thick disk. Our solar system lies in the thin disk, a relatively flat structure that formed about 4.6 billion years ago. The thick disk, however, is an ancient, more spherical part of the galaxy. It emerged several billion years earlier, when the Milky Way was still a young, chaotic sphere of stars with low amounts of heavy elements. The result of such an ancient birthplace is staggering. 3I/Atlas could be up to 7 billion years old. That's a full 2.5 billion years older than our own solar system. Astronomer Matthew Hopkins from the University of Oxford put it this way: all ordinary comets, like Halley's Comet, formed at the same time as our solar system, so they're at most 4.5 billion years old. But interstellar visitors have the potential to be far older, and according to our statistical models, 3I/Atlas is very likely the oldest comet we've ever seen. Just think about it. This frozen chunk of ice and dust has survived an era when the universe was only beginning to produce second-generation stars in large numbers, when heavy elements were much scarcer and the chemistry of planet formation was entirely different. It's like finding a fossil from a time long before Earth even existed. On October 29, the comet reached perihelion, its closest point to the Sun along its path. This is usually when comets wake up and become most spectacular. Solar radiation heats the nucleus. Frozen gases and water sublimate directly into vapor, forming a massive gaseous dusty envelope, the coma, and a characteristic glowing tail. But 3I/AT broke all the rules. It brightened far more than any existing models predicted, dramatically more. Several specialized space observatories tracked the phenomenon. The twin stereo spacecraft, the SOHO solar coronagraph, and even the meteorological satellite GOES-19, which happened to be in the right position. All of them recorded the same thing, a sharp surge in brightness that significantly exceeded the norm for Oort cloud comets at a similar distance from the Sun. The authors of the study, Qicheng Zhang from Lowell Observatory and Carl Battams from the U.S. Naval Research Laboratory, wrote in their archive paper, "The reason for this rapid brightening, which far exceeds the rate of most Oort cloud comets at similar radial distances, remains unclear." Among the possible explanations, scientists are discussing a higher concentration of supervolatile substances in the nucleus, such as carbon dioxide or amorphous water ice that perfectly preserved itself from ancient times and now explosively vaporizes upon its first serious heating. This unexpected behavior has given astronomers a unique data set on the chemical composition of comets formed under completely different conditions around completely different stars. And here we are yesterday, December 19, at 1 a.m. Eastern Time in the U.S. The comet passed its closest point to Earth, 168 million miles, or 270 million kilometers. That's roughly 700 times farther than the Moon, so there was and is no danger at all. But it's the perfect distance for detailed observations with the most powerful instruments. The Hubble Space Telescope managed to capture stunning images of the nucleus and tail. Data is still streaming in, and it will help us understand exactly what building blocks form comets and planets around other stars, and how elemental ratios vary across different parts of the galaxy. Right now, the comet is turning around and starting its outward journey. First toward the outer regions of the solar system, past Jupiter, and then finally leaving us, heading into interstellar space on a voyage through the Milky Way that has already lasted billions of years and will continue eternally. The data collected over these months will be analyzed by astronomers for a very long time to come. It's already helping to paint a more detailed and complex picture of what our galaxy truly looks like beyond the solar system, how chemistry varies across its regions and eras. If you want to track its departure in real time yourself, download the free NASA Eyes on the Solar System app. There you can see the exact trajectory and current position of 3I/ATLS right now. Farewell, 3I/ATLS. Thank you for dropping by from the ancient galaxy. You showed us a piece of the universe as it was long before the birth of the Sun and Earth, and we'll be waiting for the next interstellar visitor. Who knows what secrets it will bring? If you love these kinds of real cosmic mystery stories, hit like, subscribe, and turn on notifications. In the comments, tell me, what do you think was the most amazing thing about this comet? Links to sources and the NASA Eyes app are in the description. See you in the next cosmic adventure.